Okay, so this is I'm going to compress this talk. I've given it a bunch of times, and there's some videos about it already. Um, and since I have limited time today, I'm going to try to kind of rush through my slides, and hopefully I can give you guys an interesting demonstration about Handshake. So Handshake, ticker symbol is HNS. It is a separate blockchain. It is based on Bitcoin, so it is UTXO based blockchain with transactions like that. And it is a decentralized root zone and certificate authority secured by proof of work. So what we're going to talk about is DNS, how names work on the internet, and how SSL works, how you can connect to websites securely, and how we're going to take those roots of trust away from central authorities and secure them by proof of work, which as Bitcoin users is something we might all be a little bit more comfortable with. So I'm going to start off by talking about DNS really quickly. We probably all know that DNS is where you take a URL like bitcoin.com and it turns into an IP address. Turns out this URL is actually split into different sections based on those dots, and each of these dots is a label or a domain, and the root zone is an invisible name at the end. So when we're looking at www.bitcoin.com that dot represents the root zone. When you make a DNS query from your computer, you actually send messages to each one of these servers in order, asking, I'll just kind of run this like a couple times. So this happens if you're going to www.bitcoin.com, you actually ask the root zone first, and then you go to .com, and then Bitcoin, and then www, and this stuff can be easily looked up. So you can get the idea that the structure of DNS is like this pyramid where there's a root zone at the top that has top-level domains, com, org, net, info. There's a few hundred now. And then each of these top-level domains has their own subdomains, second-level domains like Google, Facebook, Bitcoin, AirMeet, like that. And then each of those second-level domains like Google can have even further subdomains. And these are all separated by dots. And to discover them online, your computer has to sort of query each of these servers one at a time and get an IP address for the next server until it has found the entire, until it's found the website at www.bitcoin.com. So the root zone is managed by a nonprofit organization called the Internet Corporation for Assigned Names and Numbers, also known as ICANN. They're based in Los Angeles in the United States, in California. And they, so the root zone is a collection of records that represent, .com, .org, like that. And those records are all signed by ICANN. That's how you know that they are authentic. I can't play this video because of how I'm presenting it, but they have this amusing ceremony every couple of years where the staff gets together in the basement and they unlock special equipment from a safe and generate a private key that is used to sign the root zone. And then that public key is everywhere on the internet. You can Google it, KSK 2017. It's a public key that every computer, when you buy it, every computer has it installed. You implicitly trust it. And so in that way, ICANN signs a zone, a series of records that says here's where com is and org and info. And then com has its own public key. And they say, well, this is where Bitcoin is and google.com and facebook.com and airmeet.com. And then Bitcoin has another key. It says this is where www is, this is where mail.bitcoin.com is, and like that. And so there's this chain of signatures, and it all leads up to the ICANN root zone key, which is generated in this basement in California every couple of years. So clearly, central authority, one single private key that basically secures the entire internet. Second topic is certificate authority. So this is actually different, but when you see the lock icon in your browser, that's telling you that your browser has established an encrypted connection with the web server and has also authenticated that you are talking to bitcoin.com, definitely for sure. And how this is a separate actual chain of trust. And I've taken a screenshot here of going to bitcoin.com, and you can see I've received an SSL certificate from the website that was signed by Cloudflare, which was signed by Baltimore Cyber Trust Root. Now, probably nobody in this chat, we got 55 people, I'm willing to bet nobody has heard of Baltimore Cyber Trust Root before. But if you go into your system settings and look at your certificates, this kind of list here, you'll see it in there along with hundreds of others. And these are all public keys that your operating system just trusts. When you bought a new computer, these keys were on there. So again, we're cryptocurrency users. We have an operating system that just trusts keys that belong to Baltimore Cyber Trust. Okay, and then because Baltimore Cyber Trust trusts Cloudflare and Cloudflare trusts Bitcoin.com, however they arrange that, when you go to Bitcoin.com, your browser says, okay, this is an encrypted connection. So there's these two chains of trust. There's DNS, secured by DNSSEC. DNS is where you put in a name like www.bitcoin.com. Each of those labels has its own public key signed by the parent, and the last parent is signed by ICANN, the root zone. And then over here we got certificate authority, and it's the same kind of thing. You get a public key from the web server. That key is signed by some authority, which is signed by some other authority, which is finally signed by some authority that's just installed on your computer. So as Bitcoiners or other cryptocurrency users, we look at these two roots of trust and we say, we know we can do better. We can replace them both with proof of work. And that's what the problem that Handshake solves. We're going to take that power away from these central authorities and distribute it. So HNS, a Handshake query, works basically the same way as before. If you're looking at a website like bitcoin.proofofconcept. So in this case, proof of concept is the top level domain. It's a Handshake domain. You can't access it without special software. It's not in the legacy internet. But it works the same way. The root zone is on the blockchain now. So we're not talking about a root zone signed by a bunch of nerds in the basement in California every couple of years. We're talking about a blockchain. Proof of concept is a top level domain. The data for that name is on the blockchain. Also, with a Handshake resolver, you can still access ICANN. It's not either or. They are both accessible with the same software. And how that works basically is if you ask your Handshake resolver for a name that doesn't exist on Handshake, then it just uses regular DNS. It goes back to the ICANN system. So you can still go to bitcoin.com using a Handshake resolver. And then finally, how do we tie together DNS and SSL? So I said that Handshake is a decentralized root zone and certificate authority protected by proof of work. And the trick to combine those two technologies is something called DANE, DNS-based authentication of named entities. This is not a new technology. It's not something that was invented for Handshake or by any cryptocurrency people at all. It's actually been around for many years, but it's been avoided because it's sort of unnecessary and it adds some latency, and the trust structure that we already use is good enough for people who don't care about decentralization. Long story short, what we do here is if you have an SSL certificate, you can generate them on your own. You don't need anybody to give you a certificate. It's just a public key, and we probably all know what a public key is. So you take the certificate and you hash it. Joseph provided a great explanation of what a hash is. And so that hash is a very small string. Here, the hash for this certificate on my example is this line here. And that is short enough to put into the DNS system. So now when you go to proof of concept, your resolver will find this hash and make sure that the certificate provided by the web server matches the hash in the DNS entry, which is secured by proof of work, and that's how it's done. So when you go to https://proof of concept, the Handshake resolver will go get that DNS record, so it knows what IP address the website is at. And when it contacts the website, it'll get this SSL certificate. It'll check to make sure that the certificate is the one that is committed to in the DNS records, also secured by proof of work. If everything matches, you get a green lock icon. You can now communicate securely with that website, just like you would if you went to google.com in a regular browser. So a little bit of talk about the Handshake chain. How do you get a name on Handshake? My slides are a little out of order. How do we resolve a name on Handshake? That's a little bit maybe more fun. So kind of like Bitcoin, like the design, the architecture is designed so that everybody can have their own full node. So I run a full node on my computer. I run one in the cloud. I also run one on a Raspberry Pi that just sits next to my home router. So all the devices on my Wi-Fi network at home can resolve HNS names. I set the DNS settings in your phone. I can show you how to do that. And so Handshake, the full node, the thing that actually verifies the blockchain, does the DNS resolution for you. It has this extra function built in. And there are also other bits of software that don't need to verify the entire blockchain. They don't need to do money stuff. They don't need to do the cryptocurrency stuff. They can just verify the DNS data on the blockchain. That kind of software is much easier to run and much easier to integrate into lower powered devices like phones, or like to cram into a web browser, which is would be the ideal Handshake tool. You can use an SPV node. So like I said, you don't need to download the entire blockchain. You can also trust somebody else's full node. So one example of that is NextDNS. This is a service that it's kind of like a VPN, but they just do DNS. And what their business model is you use them to resolve all the DNS on your computer, and they just block certain DNS requests that they already know are malicious. So if some website you're on tries to download an image from hackerencryptallyourdata.com, NextDNS will just not give you the IP address for that server, and so your computer remains safe. So that's kind of their business offering. And they have a Handshake option. So you can use NextDNS for free. They also have a subscription model. And if you find this little button in your settings and turn it on, you can go to all these Handshake names automatically just by typing it into your browser. No extra software needs to be installed. Another way to do it is more deep in your settings. This is how the DNS settings look on my Apple laptop. I have a Handshake full node running at this IP address, and I simply tell my laptop to do all its DNS queries to that server, and it's a full node. And actually, I have it firewalled, so not everybody can use it. I can give people access if they like, but just want to get the idea across that wherever you can install a Handshake full node, you can use that as your DNS resolver for multiple devices and access these Handshake names, which I'll show you in a second. So how are the names distributed? Where do you get them? Names come from auctions that happen on chain. It's not an Ethereum style auction. It's a Bitcoin style auction. Every step of the way takes a different transaction, and they're all UTXO based. They're all chained together. It's sort of interesting. I'll talk about that in a second. There's also some reserved names like com, info, org, also Facebook, Google. These names are reserved for the people who own them now. And that makes a lot of sense. We wouldn't want to start a DNS blockchain and have people like put a website on Google or something and they're not Google. So the founders designed this mechanism where using that ICANN key, using that chain of DNS security, those chain of signatures that we're trying to move away from, you can still use those signatures to claim your reserved name. So it's kind of interesting. If you own one of the names on the reserved name list, you can put a text record basically with your wallet address and the DNS in the domain name system, and use it kind of a proof to get that name on chain without having to go through an auction. Very cool. Coins were also distributed. There was this massive airdrop. If you had more than 15 followers on GitHub in, I think it's February, I wrote down 2018, you can use this tool called HS Airdrop to basically generate 4,000 HNS to your wallet address instantly. The founders of the protocol deeply believed in open source software and developer contributions and stuff like that. And so actually a huge portion of the overall potential maximum coin supply is going to this airdrop. Okay, so let's talk about the auctions a little bit, and then hopefully I can do a demonstration and everything will work. We'll see. This is a little bit of a complicated diagram. I've even simplified it a little bit, but these are sort of the terms you might see if you are bidding on a Handshake name. Names go through these steps, and each step has a certain amount of time that phase is sort of locked into. So you open an auction by setting a transaction. I want to open an auction for BLOCKDeFi. That's a top-level domain that I want to own on Handshake. A few minutes later, the bidding starts, and anybody on the network can see that name auction is open and that bidding has begun. Bidding lasts for 5 days, and bidding is blinded. So you actually send a little bit more Handshake tokens than your actual bid, and that difference sort of blinds it. So if I only want to bid 1 HNS on BLOCKDeFi, I can actually send a transaction for 1,000 HNS, and nobody knows what my actual bid is. And that blindness is part of the game, part of the process to discover the market value of an asset. So those blinds need to be revealed after bidding is closed. After 5 days, you have 10 days to reveal. You must reveal or you lose your money. Again, it's part of the game. And then the winner of the auction pays the second highest bid. So if I bid 100 on a name and Joseph bid 50, I won the auction because I have the highest bid, but I only pay 50. I pay the second highest price. And again, this is part of a mechanism called the Vickery auction, which is designed to find the fair market value of an asset. Once you've won a name in an auction, you go through the stuff on the right of the slide here. Register, update. You can transfer the name. Register, update. These are how you add DNS data to your name, put it on the blockchain. Transfer, finalize. You can send a name to any address, any Handshake address, and renew is something you have to do every 2 years. So how do you get a name? I'm going to show you 2 ways and then do a demonstration. One way is to use namebase.io. They are the first Handshake exchange that has this type of registration function. This type of auction function. They were very helpful developing Handshake all through testnet. Great staff over there, very helpful Handshake experts. So I know they operate in the United States. I'm not sure what other countries they operate in, but there are plenty of other exchanges around the world where you can now buy and sell Handshake tokens. But Namebase is the only one I know of currently where you can actually participate in these auctions and bid on names. So here's a screenshot of namebase.io. What the auction looks like for the top level domain medical, and you can kind of see how the bids are there, and they list the lockups, which is that like extra little amount of money that, I can't, if somebody bids 888 Handshake, I don't actually know that that's the value of their bid. I know their bid is below that, but that's like the blinded level. And then in the reveal phase, we find out what their actual bid was. I'm going to demonstrate in a second how to use Bob Wallet. They actually have an easier website now just called bobwallet.io. And I'll demonstrate this. It's an Electron app that wraps a full node. You can think of it kind of like Bitcoin Core, but for Handshake. It does all the money stuff that you would expect, your 24-word seed, generates addresses, you can send and receive money. But Bob Wallet also does the auction participation and the DNS registration stuff. So before I get into the demonstration, I do want to talk about two other little projects that you can use. So the idea of, you get a name on Handshake. A lot of people are speculating on names. They buy a name now, they want to sell it later, or they want to sell subdomains for their name, that kind of thing. For those of you who are excited about actually building a decentralized website and owning a name that nobody can take from you, that there's no root of trust above you, it's just a blockchain and you and your private key and you own that name. I've written a piece of software called Handout, which is open source and it's on GitHub. And what this program will do, and I'll demonstrate it for you hopefully in a second, is it spins up a web server to serve your website. It also runs a name server, which is a type of DNS server that provides DNS records. Not all the DNS records come directly from the blockchain. You can think of it as a layer 2 or an application. We don't really need to go into it, but you need it if you want to have a decentralized website on Handshake. And the other thing this script will do is generate all your keys. It'll generate an SSL certificate. It'll set up the DNSSEC. It'll set up the DANE. Everything's good to go. And then people can securely browse to your website. For people who want to securely browse to your website, you need one extra little piece of software. So as I've explained, Handshake does two things. It does DNS and it does a certificate authority. And getting the DNS part figured out is actually kind of easy. You can use NextDNS, or you can use a Handshake resolver like I've described, or a full node, and you can type in a Handshake name and your browser just goes there. Your browser doesn't even know that you're going to a Handshake domain. It doesn't even matter. But the security is a little tougher because browsers are not configured for DANE. Browsers expect that your SSL certificate will be signed by some root of trust. And if you're savvy, you can add your own root of trust to your computer. So what GoDane does, there's a diagram here in the middle, which I wanted to highlight. What GoDane does is it generates a certificate just for you, and it installs it in your browser. You can install it in the operating system or just in Firefox, which is kind of a clever mechanism. And then GoDane will check those DANE records. It will contact the Handshake DNS resolver that you specify and get that TLSA record and make sure that the SSL certificate coming from the web server matches the record. And if that's all good, if the security is valid, then GoDane, with its own certificate, will sign will sign the certificate of the website the same way. So it's like a little local authority figure. It's a certificate authority that you control, that you install on your computer, and you tell your operating system to trust it. And it it goes between the web server on the internet and the browser, and it signs these certificates on the fly. It's very clever. I'll demonstrate it how it works in a second. Obviously, this isn't ideal. This isn't something the average internet user is going to want to do. This is the state of the art right now, and I'd like to see technology like this integrated into individual web browsers, operating systems. Who knows? Maybe Handshake gets so popular, we see a Linux distribution, in a few weeks, months, whatever, years, where this stuff is built in. Okay, so I have my Firefox configured to both resolve Handshake names using a DNS over HTTPS server down here. So this is my Handshake resolver. And then the GoDane proxy is also running on my computer on port 8080. So this is very simple to set up. You can see I just needed to fill in a couple fields. And then that certificate that GoDane generated is also installed in Firefox. And if you're interested, you can learn about how to do that. So this is a site that I run. It's called Proof of Concept. You'll notice in the URL, there's no dots. It's just https:// proof of concept. This is unusual. It's a website that lives right on a top level domain. And this is a name that I won in an auction on Handshake. And I control it with my private keys. And nobody can take it away from me as long as I still control my private keys. It runs on Handout, that server software that I showed you a second ago. So it has a name server and the web server built in. And I've coded it to so that, if you want a subdomain, you could pick any subdomain, and lots of people have added their subdomains. Alan has signed up, Spring Cleaning has signed up, and these people have subdomains. So now we're here at michaeldeguzman.proofofconcept, and you can see this user's URL here, and they get to update their status. So, it's a proof of concept. It's kind of like Twitter. All the users get their own subdomains, and then they can post these messages, and you can kind of see them all in the history. But what's particularly interesting about proof of concept is that this is a secure website. And the reason I wanted to design it like this is because, you should not be typing any type of password or any type of username, password, no credentials at all should go into any web browser that is not secure, that has that lock icon. Otherwise, your password is going over the internet unencrypted. Everyone in the world has got your password. And similarly, you should not trust data you see on a website that doesn't have SSL. If someone says, here, my name is Joseph Peculiar, here's my Bitcoin address, if it's not secured by SSL, you can't trust that. Any other server along the way could have replaced Joseph's Bitcoin address with the attacker Bitcoin address. You can't trust it. But using this DANE system, this web browser is secure. This website is secure. You can see it says verified by a DNS sec. So this is very different than the screenshot I showed you where Bitcoin.com is secured by Cloudflare, which is secured by Baltimore Cyber Trust or whatever it was. This is proof of concept. It's secured by the blockchain. Isn't that amazing? I have a couple other Handshake sites. It's just kind of interesting to see http://2D. So 2D, just a 2-character name. This is just for fun. And Will Cruteau has this other site. You can see the URL is just http Will Cruteau. And I'm not sure what the deal is, but I love this website because it's psychedelic and these cows and like little Donald Trump faces fly around, and it's just very silly. But also it's worth noting that this lock icon is slashed here, and that's the browser telling you don't trust any information on this site and don't type any sensitive information into this site, because these two users did not set up DANE. But in proof of concept, you can see there's a lock there and it's secure. All right, so we've got a little bit of time left, and hopefully I can show you sort of what the interface is. So what I've got here is Bob Wallet. This is our GUI. Like I said, it's kind of like Bitcoin Core. It runs a full node, and you can do all of your money stuff with it, as well as the name auction and bidding and DNS stuff. So this is only on Reg Test, which means that this is a local test network that is only running on my computer. I'm not connected to the world. None of the money is real. It's just a test network. But there is mining. So for example, I have another full node running in the background, and I can generate a block. And we'll see on the right side that that block, gets added, and now we're up to height 210 in Bob. Okay, so let's look for a name, and hopefully I don't embarrass myself with this presentation, and we'll see. So I want the name BLOCKDeFi. I want that to be my top-level domain, and next year we can do the conference at https BLOCKDeFi, no dots. So the first thing we do is we start an auction. Now this requires a transaction. So I type in my password, it's signed with my private key, and you can see in the logs here, like a transaction went out, just as if you were sending money. In this case, what I'm doing is sending a message to the network that says, hey, BLOCKDeFi is a name that I want, or that somebody might want, and the auction is starting. So now what I'm going to do is sneak back to my console and generate some blocks. And that's because when you open an auction, it actually takes some time before the bidding starts. So now we're 7 blocks into the future, and now we can place a bid. So Bob is telling me that we're in the bidding period now, and we can place a bid on this auction. So let's do that. I'm going to bid 1 HNS, and there's this add disguise option, and I'm going to disguise it with 10 HNS. So what this means is that on the blockchain, it's public, everybody is going to be able to see this transaction for 10 HNS. But is that really what I'm bidding on BLOCKDeFi? No, it's not. That's a blind. So nobody really knows what anybody else's bid is, although they might be able to guess. So the total amount of money I'm going to send is 11. I guess I could have done this a little differently, but that's what's going to happen. So here we go. Password goes in. Transaction goes out on the network. Now there's a transaction for 11 HNS out on the network. It's really a secret bid for 1 handshake. I'm going to generate 1 more block and kind of just toggle back and forth to reset the UI here. I'm going to place another bid just for fun. This time I'm going to bid 2 handshake with no disguise. Why not? No disguise this time, just to show you that it's optional. Okay. Generate 7 blocks, I think. And where are we now? So you can see the wallet shows me that I've sent 11 HNS in one transaction, 2 HNS in another transaction. We can go look at the BLOCKDeFi screen, and you see that the bids are down here. Now, if somebody else who is not me bid on this auction, you would see their bid down here as well, but you would not know what the bid value is. There'd basically be a question mark. We know what the mask is. They're blind, but we don't know what they actually bid. So now we are in the reveal period. And like I said, you have to reveal your bids because they're blinded. And part of the rules is that the network needs to know what your real bid was so that a winner can be determined. No options are necessary here. You just click the button. This is another transaction that goes out on the network. This transaction will actually reveal both of my bids for this auction. And we can generate a few more blocks to kind of skip ahead in time. Again, the reveal period on Handshake mainnet takes 10 days. So everybody has plenty of time to reveal their bids. So in Bob Wallet, we can see my bids. One of my bids won and the other one lost, obviously. The losing bid for one HNS, I can redeem. This is another transaction type that takes the money out of the auction back into the wallet, so I can now spend that again. And then the winning bid has the opportunity to add DNS records. So now we can register this name, and this is a DNS type interface. You'll recognize it from GoDaddy or from Namebase even. And let's just say this is an awesome conference. This is a text record. It's a type of record that's allowed in DNS on the blockchain. And we'll submit this like another transaction. So I now own the name BlockDeFi, and I'm updating the DNS records for it, all on the blockchain, all decentralized. Again, I'll move the chain forward a little bit, and hopefully this is all working. All right, so here comes the real test. Now what I'm going to do is, yes, BlockDeFi txt. Fantastic. Okay, so the command I just typed is dig, which is a command that looks up DNS records. I've added some parameters to tell it to look at my reg test node, so it's not actually doing a DNS lookup the way you would if you were browsing the web. It's asking like my little test network. And so I asked it for the name BlockDeFi, for the text record for the name BlockDeFi, and here it is, clear as day. This is an awesome conference. It's right there. So if I had a website up at https://blockdefi, I could have added, oops, I don't want to renew just yet. I want to manage. You can add another record, and these other record types like DS, NS, glue, and synth, these are more advanced record types, but this is how you add the IP address of your website onto the blockchain. Really quickly, I will show you how Handout works. Let me switch to the right place. So if you were going to install Handout to launch a secure website on your Handshake top-level domain BlockDeFi, you run it in Node.js, and my website or my TLD is BlockDeFi, and let's say that my IP address is 10.20.30.40. Why not? So this script will generate an SSL key for me and a self-signed certificate. It'll generate the DNS sec keys. These are the keys that go into the DNS records, and there, we're all done. So what you could do is you take like this DS record here, and that is telling the blockchain what your public key is. And then that key is actually used to sign everything else in your DNS zone. So I kind of wave my hand at that a little bit, but you know, we all, being cryptocurrency users, understand like public keys, private keys, signatures, messages, stuff like that. This is the DNS version of that. I give you my public key, I sign some stuff that says, hey, my IP address is 10.20.30.40. And then when your computer goes to https://blockdefi, they get the website from the right IP address. They can verify that all the signatures are correct, all that kind of stuff. So I should be able to now look up the DS record from BlockDeFi, and there it is. Okay, so this is something the browser would do in the background to check all the signatures. And actually, let me see if I can do DNSSEC here. Okay, yeah. So I added a DNSSEC flag, and this RRSig, it's a signature that's available in the DNS system. Just wanted to illustrate that is a thing. So I know I rushed through everything, but I hope that was cool and maybe inspires some of you to learn more about Handshake. I pasted all those links in there. I live on Telegram and on IRC, and you can find me there. So I'm going to look in the chat for some questions now and see what people are asking. How does this interact with Microsoft Word keychain or certificate in a computer, and where can it be located? Okay, so I'm most familiar with OS X, with the Mac operating system, and in your, if you go to utilities, there's this program called Keychain Access, and here you can see, all the keys that are trusted on my system. And this, if you do the Go DANE route, your key could go in here. I think I might be able to show you if I have my DNSSEC key. This would be installing it on the system level. Okay, there's my DNSSEC key, and oh, this is from an earlier test, but you go in here and you tell the computer you want to trust it. I'm not going to do that now. But also, if you're using GoDane, the instructions on the GoDane GitHub will illustrate how to just install the certificate just in Firefox. Firefox is awesome when it comes to security options, in the sense that you can make it insecure by putting your own certificate in there, but that's something that really makes Handshake work. There's a question about unstoppable domains. That's totally valid question. Ethereum naming system, or ENS, is also another cryptocurrency block naming system. There's a lot of differences. First of all, Handshake names are top level domains. It is a root zone. Unstoppable domains names go into .crypto or .zil. ENS names go into .eth. So one of the big differences is that Handshake is a root zone, not a subdomain. And there's other little differences. Handshake is not Ethereum. It's its own blockchain. It was designed from the ground up with special data structures and certain types of proofs to work quickly on low-powered hardware just for DNS. There's no CryptoKitties on Handshake. There's no anything. There's no smart contracts. It's just DNS. And so being very single purpose like that gives it a huge advantage to be optimized. The trade-off is, we don't have the security that Ethereum does. If you do something on Ethereum, you have that level of security that you can expect from anything on Ethereum. The problem is that there's a lot more data to verify, and all that stuff is a lot slower. Handshake is really designed for, the freedom, the crypto anarchist idea that you can run a piece of software on your computer that verifies everything and does it quickly. Can you share a link to have access to your slides? I think I've done that. Let me see. Are there any more questions? Okay, thanks. If there's any more questions, you can ask them now. Otherwise, I think we're pretty much out of time. And thank you so much for having me and giving me the opportunity to talk about Handshake. Imagine IPFS process. Yeah, actually, so I've been working with some engineers at Saya, which is another decentralized file storage system that also has its own blockchain, but otherwise works like IPFS in that there's a distributed system where you can store data. And they recently had a hackathon where a lot of really interesting projects came out of that. And they have these portals that anybody can run where you can attach a Skynet link. Skynet is what they call their distributed file system. You can attach a Skynet link to a Handshake name. And so you can go to http:// proof of concept, and the server will proxy the Sia link and actually give you the data from the decentralized storage. And you can imagine this happening with IPFS just as well. Like Joseph talked about the content locators that IPFS provides. You can put one of those content locators in a text record in a DNS resource on the Handshake blockchain. Thing would work the same way, just so long as the people looking for your site have the software to decode it. All right, if there's no more questions, then I just want to thank you all again. And the links are there and the slides are posted. And I hope everybody has a great rest of their day or evening. Thank you.